All right, now let's talk about what effect it has if you change the dimensions of your figure. Okay, so I have a little chart here that shows what effect it has. Okay, so we talked about perimeter and area earlier in the course, but let's just remember. So if you multiply the dimensions of a figure, all of the dimensions by a number, the perimeter is affected by that same number. You just multiply the original perimeter by that same number and you'll come out fine of a figure. If you're finding the area of something, since its area is two-dimensional, length times width, you're actually multiplying your original area by that number squared to get your new area. Volume is three-dimensional, so what happens there is you're multiplying by that number cubed, and that gives you your new area. So if we were just going to try and just by working it through, answer a question like this. Let's do it, and then we'll fill out the chart, and you can make a choice whether you want to do by trial to find out what the change is, or if you want to just use the rule. So down here it says the length, width, and height of this prism are tripled. Describe the effect on the volume. Well, let's find the volume beforehand, because this is the method that some people might use to answer this question. Okay, go ahead and find the volume. It's a rectangular prism, so we find the volume by doing length times width times height. In this case, 5 times 8 times 2, which gives us a volume of 80 cubic inches. Okay, let's say, however, that those dimensions are tripled, like they said here. They're all multiplied by 3. And this is going to be a really poor drawing, but we'll try it. Okay, so let's say we made it bigger. We made it bigger by tripling everything. So 2 times 3 gives me a dimensions of 6 here. 8 times 3 gives me a 24th here. And 5 times 3 gives me 15 here. This is my new figure. How is the volume affected? Well, to know that, we have to find the volume. So the volume here, again, would be length times width times height. But this time it's 15 times 24 times 6. That gives me 2,160. So by just tripling each of our measurements, notice the change. It went from 80 to 2,160. And that would be in cubic inches. So what was the effect? How many times greater is the new from the old? So we're going to take the new, divide it by the old to find out what effect it had. The new volume is 2,160, okay? The old volume was just 80, and if you divide those, you get 27. So the effect is that it's 27 times greater, the volume is, when you triple, okay? Notice that's the same as if I had used my chart up here. Now, the instructions said that the dimensions were tripled, so they were multiplied by 3. Well, if I use my chart, that tells me my volume. How would it be affected? It would be multiplied by 3 to the third power. And what is 3 to the third power? It's 27. 3 times 3 times 3 is 27. So this is a much faster way, but to give you an understanding, this is what actually happened down here. We had a volume of 80. We tripled everything, which meant you had, look at this, 15 is the 3 times 5. 24 is the 3 times 8, and 6 is the 3 times 2. So we had a 3, and another 3 multiplied in. That's where 3 to the third comes in. Either way, it's 27 times. So let's say they gave you a figure and all they told you is that the dimensions were all multiplied by 4. What would be the effect on the perimeter? Well, the perimeter of your original would be multiplied by 4. What would be the effect on the area? The area would be multiplied by 4 squared, which is 16. And the volume, how would the volume be affected? It would be affected it would be multiplied by 4 to the third power, which is 4 times 4 times 4, or 64. So it would be 64 times the volume. What about 1/4? Well, how would your perimeter be affected? It would be 1/4 the size. How would your area be affected? It would be times 1/4 squared. Okay, and when you square a fraction, you just square the top. 1 times 1 is 1. Square the bottom. 4 times 4 is 16. 1/16 the size. And if the volume would be that number cubed, so it would be 1/4 to the third power. So it would be 1 over 4 to the third power, which was 64. It would be times 1/64. Okay, you can use either method. You can go ahead and find the volume of the original one and find the volume of the new one and then divide to find out how many times larger it is. Or you can just use the rule that the volume is affected only if all of the dimensions are changed. It's affected by the number to the third power is how it's affected, and I'll do both. Okay, so on this example it says the length, the width, and the height, all 3 dimensions, are doubled. Describe the effect on the volume. Well, doubled means times 2, and we talked about on our chart that the volume is affected by that number to the third power. So 2 to the third power, 2 times 2 times 2 is 8. So I'm predicting that it will be 8 times the size. That's my prediction. Let's try it out. Let's do the actual work here. So here is our prism. We want to find the volume of this prism, which is going to be the area of the base times the height. Okay, so let's find out where's our base. We want the 2 figures that are exactly the same shape. So that would be here. This is our base, and this is our base. Okay, and then the 7 would be the height. So our height is 7. Ka-ching. We have to find the area of the base. Okay, what shape is that? That is a parallelogram, and the area of a parallelogram is equal to the base times the height. Okay, the base of the parallelogram times the height. Now, the base of the parallelogram is 5. The height is 3.5. Notice this is showing us how far it is from here to here. So the height would be 3.5. So the area of our base is 5 times 3.5, 17.5. Okay, so our volume will be 17.5, the area of our base, times 7, which was our height, and we get a volume of 122.5. Okay, this is our old volume. Let's take a look. What would our new volume be? If we double, that means to take everything times 2. So instead this would be 5 times 2 would be 10. This would be 2 times 7, 14. And this would be 3.5 times 2 is 7. So now, let's find our new volume after all of those have been doubled. Okay, we're still doing that the volume is the area of the base times the height. Oh, I can't get the right color. Sorry about that. Okay. Okay, so now our height is 14. And the area of our base is going to be 10 times 7. Okay, that height is 7. 10 times 7. Or 70. Okay, let's go ahead and multiply those together. 70 times 14 gives me 980. So my volume was 17.5. Now it's 980. Our original was a volume of 122.5. Now it's 980. So to find the effect, if you're doing it this way, what you do is you take the new volume and divide it by the old volume. So again, our new volume was 980 after we doubled all the dimensions, and the old was 122.5. 980 divided by 122.5 is a change of 8 times the volume. Okay, so you can see I was able to, just using our properties, to predict at the very beginning what would happen. Okay, but you can, if you're more comfortable with finding the volume before, finding the volume after, you're welcome to do that. Otherwise, what you do is you take whatever it's multiplied by, as long as all dimensions, length, width, and height, are used. Um, you take that number, it was multiplied by 2, each of them, and you take it to the third power, and that will tell you what effect it has on the volume.